Hello everyone, my name is Firas Shari, CW 348. Today we're going to be talking about the SU-MIMO and MU-MIMO as a part of this series of 8 to 11 AX training. In this video we're gonna just explain what is SU-MIMO and what is multi-user MIMO, and we're gonna look at the difference between how multi-user MIMO is done in AC compared to how it's done in AX. Okay, so a quick recap of the history of MIMO and its both of its flavors, the SU-MIMO and multi-user MIMO. So SU-MIMO was introduced with the 8211N standard, and it allowed the AB to transmit more than one spatial stream to the clients. Basically, the idea is like the AB will have uh, more than a transceiver, more than one transceiver. So to send, for example, 4 spatial streams, the AB is required to have 4 transceivers and 4 separate antennas, one antenna for each transceiver. And by knowing the channel conditions and constructing a signal that has all those spatial streams or signal to each other, that will allow the AB to send those 4 spatial streams um, in parallel to each other. Of course, the receiver has to have 4 antennas as well and 4 spatial streams, and 4 transceivers to receive 4 spatial streams. So if the other side is a client, is a 2x2 client, so the AB will be limited to only 2 spatial streams, even though even if it's capable of sending 4, it will only be able to send a 2x2 stream, 2 streams to the a 2x2 client. Okay, MU-MIMO. MU-MIMO was introduced with the H211 AC, and the idea is like instead of the AP sending all the spatial streams to one specific client, the AB will like distribute those spatial streams on different clients. So for example, if we have an AB with a 4x4 spatial streams and 4 clients connected to it, the AB can actually dedicate 1 spatial stream per client, and send all communicate to all those clients on the downlink simultaneously. I mean, it could be any combination of like the maximum number of spatial streams you can support. So for example, if the AB can support it has an 8x8, that means that it can support 8 spatial streams, and with 4 clients, it can do like 2 spatial streams to a client, or like it can do 4 spatial streams to one client and distribute the rest of the clients to the rest of the spatial streams on the what is left. So it could be any combination of the maximum number of clients you have. Okay, in the picture here, we see the difference between multi-user MIMO and SU-MIMO. So in the picture on the left here, we can see a depiction of multi-user MIMO, where the AB transmits 4 different spatial streams to 4 different clients at the same time on the downlink. In the SU-MIMO mode, you have 4 spatial streams. The AB is capable of 4 spatial streams, but it's transfer all of them to one client. And like I said, for the AB to transmit all the spatial streams to one client, the client is required to have the capability to receive 4 clients. So it has to have um, you know um, four transceiver and 4 separate antennas, one for each transceiver. Okay. Multi-user MIMO, like I said, is not a new concept. It has been around as a part of the AC standard. But the way that it was implemented, it was more of a tedious and a little bit complicated process, and it had a lot of overhead to it, which made it kind of like impractical when it comes to everyday applications. Since the overhead was like too high, the AB could not justify using multi-user MIMO unless you have unrealistic like numbers of throughputs. So you're talking about usually you don't see multi-user MIMO kicks in AC unless you're talking about like 100 or 150 Mbps per second to each client, which is not a realistic like throughput numbers in everyday scenario. So most of the time, the AB will just do SU-MIMO because of like the overhead associated with the multi-user MIMO. In AX, the whole process, like the whole process, is totally different. Like we still do multi-user MIMO in the downlink, and now with Wave 2, we will be able to actually do multi-user MIMO on the uplink as well. But that's that's a story for a different time. But for now, when we're talking about the downlink multi-user MIMO, the whole process, the whole process that the AP uses to perform a multi-user MIMO on the downlink is totally different from how it used to be done with AC. With AC, there used to be some grouping, you have to be a part of the group, and the order of the client in that group is very important. It depends on like who the AP will assign like a sequence for all those clients in the group. So client one is required to actually reply without being pulled, and so the client needs to be pulled. We'll look at that more details in the next slide. But the whole process, the way it was done or implemented in AC is totally different from how we do it now in AX. Okay, so let's look at the whole sequence of a downlink multi-user MIMO process, and the main key factor for downlink multi-user MIMO is beamforming. Beamforming enables the AB to actually introduce nulls in the transmitted signal. Those nulls will allow the AB to focus the spatial streams to specific clients and null them in the direction of other clients. Basically the AB will like focus that power for a specific spatial streams in the direction of an intended client, and it will null that power in the other directions. So the beamforming process is very important, and one can argue is like multi-user MIMO, the whole process is just beamforming. The difference between MU-MIMO and SU-MIMO is like you beamform to different clients instead of like in SU-MIMO you beamform to one client. So the whole process starts with the AB sending, an FDB, an NDB management frame, announcement frame. So the NDB is a null data packet. It's a packet that the clients will use to determine the channel, the status of the channel. So the AB will first announce that it's gonna transmit after a CIFS time. It's gonna transmit an NDB, and then it will transmit the NDB after another CIFS time. The first client that in the group will reply back with the channel estimation as something called a compressed beamforming report. So here again, like the sequence is very important. Now that like the first client is required to reply back after CIFS time, right after the arrival of the NDB packet. So the NDB is a predetermined like packet that the AP will send, and the clients will like look at that AP, look at that the received signal, compare them, use that to process what the channel conditions are, and then send an estimation of the channel condition in a feedback back to the AP. So the first client is required to process that NDB, come up with the channel response, and send it back within a CIFS time. And that actually can cause a problem, because if the client does not, does not have enough time to actually process the NDB, create a compressed beamforming report, and send it back to the AB, excuse me, within a CIFS time, that will cause that will interrupt the whole beam multi-user MIMO downlink process. So then for the next clients, how many, it doesn't matter how many of them, but like if in this example we have two of them. So if you're doing two of them, the AP will need to pull each one of them in sequence. So it will send beamforming report pull to the second client. Then after CIFS time, the client will reply also by its compressed beamforming report. Then after another CIFS time, the AB will send another pull, beamforming report pull to the third client, and that client will also reply back after 6 times. So now the AB has the channel estimation from the point of view of all the 3 clients participating on the downlink MU-MIMO. So now the AB is ready to send those spatial streams on the downlink. The AB will use those channel estimation to introduce phases in the signal, in the transmitted signal. Those will like create nulls in certain areas in the signal, which will like increase the power of a specific spatial stream in the direction of a specific client and null it in the other direction. And so now the AB is transmitting 3 spatial streams on the downlink. Each one of them, of course, includes an aggregated MBTU, and each one is destined to a specific client. Okay, and now back again to the sequence. Okay, the order of the clients in the group. So now, as we saw before, the first client is actually required to reply back with the block acknowledgement right after 6 time from receiving the MPDU. Then the AP will pull the other clients for their block acknowledgement by sending something called a block acknowledgement report. So the AB will send that first to the second client. Then the second client will reply, and after another 6 time, the AB will send a block acknowledgement request to the third client, and then the third client will reply back. So this is the whole process. Like you can see like it's a tedious process. It's prone to interruptions because of the how the first client is required to always reply back after 6 time, and also like there's a lot of overhead in this process. So it is only justified when there is a high throughput load for all 3 clients. Okay, so this is actually the whole like packet capture of the process, and if we see here, like the first thing is the NDB announcement. So the AB will send the NDB announcement frame. The second, right after that, is the NDB itself. And then the first we see here, the first action frame. This is the beamforming report. This is what the AB will. This is where the first client will reply back with its compressed beamforming report, and then the AP will send the beamforming report pool to the second client, and then the second client will reply back with its beamforming report compressed feedback. Likewise for the third client, and then also for the fourth client. In this example, I had 4 clients doing multi-user MIMO on the downlink. The problem is with the data itself, since it's beamformed, so it is like it's very hard to capture that, almost impossible to capture that beamformed data, since it is tailored in space for that specific client. So the sniffer may not be able to sniff that. If we see here, this is the NDB announcement frame. So you can see the type is the NDB announcement frame, and list of the clients who are who need to participate in this, or who should expect the NDB. And you see like station 1, station 0, 1, 2, and 3, which is like 4 clients. And then we have actually the actual beamforming feedback here. This is what the clients will send back to the AP. This is the compressed beamforming report that you can see here. The type is action frame. And if we go down here, you can see that type is like VHT compressed beamforming. It has all the information needed to the AP to create a beamformed signal on the downlink. This is the beamforming pool frame. So this is what the AP uses to request the client to send the beamforming report back on the uplink. So you see, is the name here, type is like beamforming report pool, and it is it is destined, of course, to a specific client. Okay. So downlink multi-user MIMO for AX. Downlink multi-user MIMO is, like I said, it is a very different process. It starts with the same, like it starts with, NDB announcement. So the NDB announcement is, telling the clients who's going to be participating in this, downlink multi-user MIMO, transmission. And then the AB after access time will send the NDB itself. The clients will receive that, right? And then the right after that, the AB will say something called a trigger beamforming report pool. So this is actually a similar trigger to the OFDMA uplink process. So what the AB will does here, what the AB will do is send this trigger to actually schedule an OFDMA uplink that will, help all the clients to send their, beamforming report back to the AP like at the same time. So instead of like wasting time, like, pulling all clients one by one, all the three clients all the three clients will send their compressed beamforming report back to the AP on an uplink of DMA transmission. Okay, so now the AB got all the compressed beamforming report. Now it's ready. It has like all the information needed about the channel. It is ready for a downlink, downlink multi-user MIMO transmission. So now it can transmit all three AMPDU to those like three clients separated in space and each one of them. So after this, it is sent, like after a SIFS time, the AB will send something called like MU block acknowledgement report. So basically, this is like an MU version, a multi-user version of the block acknowledgement request we saw in the VHT. It's just so this is distant to all clients, and it will like schedule them for the for an uplink of DMA. So for all clients, what they're gonna do is like they're gonna send their acknowledgement, the block acknowledgement back on the uplink using off DMA that has been scheduled by the MU par trigger. Okay, so as we saw, like off DMA, actually off DMA uplink is an essential part of the downlink multi-user MIMO in the AX standard. So it's like to do multi-user MIMO, you need to be able to do uplink off DMA as well. Okay, so here like a package capture. So I mean the stuff that it goes as off DMA, it's a bit tedious to like capture that, but well, we can always easily look at the management frames because those are like sent on the 20 megahertz, so we can capture them even with a legacy sniffer, and that will help us put together what's going on. So like I said, the first thing is the NDB announcement. So the AB will start with the NDB announcement. It's telling all the clients that who's going to be participating in this upcoming downlink multi-user MIMO. It lists all four clients here. Then the second is the AB will actually send the trigger, the beamforming pull report trigger, and if we go back to the uplink off DMA, this has the exactly similar data information that is available in the basic trigger that is used for uplink off DMA. So, but this one is specifically to pull all the clients to upload their compressed beamforming channel estimation on the uplink. Okay, so it's like it is there's a common part, and there is like per client part, which it tells each one of them what type of the RU allocation, the MCS rate they're going to be using, how many spatial streams, like the targeted RSSI, all the parameters that we saw in the uplink of DMA, everything is here, right? And like I said, it's a pure uplink of DMA process. Okay, and this is also like the rest of the frame. So we can see here, this is what the the rest of the clients are. So it's like we have 1, 2, 3, 4. The rest of the processes. What we saw here is the trigger beamforming, and then you have the uplink multi-user MIMO compressed beamforming, which is are uploaded in an off-domain format, so we don't have that. The next is the downlink, which is basically um, a tailored in space MU-MIMO transmission, so it is actually hard to capture that. The other part is the MU. Actually, in the AV that I was using in this test, the MU power is added to the data. The trigger is added to the data. It's not a separate one. So there is no MU bar separate frame. It's just a bar of the data frame coming down to the clients, and the BA, the block acknowledgement from those clients are actually transmitted on the uplink using off-DMA. So we don't have a capture of that as well. That's why we only have here the NDB announcement and the trigger beamforming. But if there was a PAR trigger frame, that would look almost identical to what you see here with the beamforming report pool, and also similar to what we saw with the basic trigger frame for uplink off DMA as well, since all those operations at the end of the day, they're just uplink off DMA. So they don't really change a lot between one to the other one. But in general, the multi-user MIMO, process is, like as we said, is a very different, process, and very compressed one compared to what we used to see in AC. There is a lot of overhead that has been shaved off the process by using off DMA on the uplink to to solicitate the compressed beamforming reports that compared to like pooling those clients one by one as we used to do in AC. Okay, so this is an overall downlink MU-MIMO process. I hope this was a helpful video. I still have I'll keep that for another video, but I would like to add more, some packet capture that actually will show some of the when the AB, how often the AB does the beamforming request pool, and how often it doesn't when it's not doing multi-user MIMO. Thank you very much. I hope you guys find this video very helpful. Please let me know if I have missed you know misunderstood any of those concepts, or there's something that I represented in not a correct and incorrect way. Please reach out to me so I can fix that and help spread the correct information.